Hey there crew, this will be looking into exercise 5F, finding the equation of straight line graphs. This video is for the students who were on the writers camp, but I'm sure I'll probably use this in the future for any other time we need to fill in the calendar with videos. I don't know what I'm on about. It's the end of the day. I'm pretty tired, but we'll get straight into it. 5F will be looking into trying to make an equation using two different methods. The first one's called the intercept slope method. This is a method where a y-intercept has been visually shown to you within a graph, as we can see in this example 17. And then we use two particular points to find the slope, and then we go ahead and construct the equation. And then the second process is be able to use 2 points on a graph to find the equation of a straight line. So before we've been using 2 points on a graph to find what the slope is. Now we're going to take it that step further and actually complete the structure of an equation. It's a bit more algebraic process that is involved, and it is easy to fall into the cracks of making a mistake. So I'll show a few hints and tips on how to make sure that we land this safely and as accurately as possible. So for now, example 17, we'll jump straight into it. We're going to determine the equation of the straight line graph shown opposite. So what it means is as soon as we see an equation and you think of the word equation, EQUA, we're looking for something that has an equal sign. And remember, I was using the word function. So there's an equation or a function. We need something that follows the template of y is equal to a plus bx. A plus bx. And what we're trying to find is what is a y-intercept and what is a slope. In this case here, it's quite simple to know what the y-intercept is, simply because we can see visually it's explicitly told to us through this graph. In other words, when x is equal to 0, a corresponding y value is positive 2. It slices through that y part of the axis at 2. And what we need is, in order to get the slope of a graph, if it hasn't been explicitly told to us, we need to have at least 2 points to be able to determine this. Now, a point hasn't been obviously given to us, and in fact some of these points are quite misleading in terms of like what they represent. Like, is that 1.5? Is that exactly f4? Is it a smidge up? Sometimes they're pretty explicitly obvious visually anyway, so what it's trying to showcase. In this type of example, it's almost quite cryptic. So some people could use 3.5 and 7. I'm going to use this point here, which is a 5 and a 9. So when x is equal to 5, which we can see, I'll just move myself here. When x is equal to 5, a corresponding y value is going to be 9. Now remember, with the textbook examples, it's not my favorite. They have inconsistent spacing or scaling with the x-axis and the y-axis. So there's a spacing of each grid represents half, but here each grid represents 1. It's quite annoying. So just be mindful of that when you get examples in the textbook. So following our template, we already know what a is. A, which is our y-intercept, is equal to 2, and provided to us in there. What we need to do is just use our slope equation in order to determine b, and then we can plug this into our template formula. So in other words, y2 minus y1 over x2 minus x1 is the equation of our slope. And make sure that when you do label this, we label this visually from left to right. So this is x1, y1, and this here is x2, y2. So we've got our first corresponding pair of coordinates, hence the 1, and our second pair of corresponding coordinates, which is 2. And now we just plug this in and make sure that our arithmetic is executed correctly. So y2 is 9, y1 is 2. So there's a difference between the y values. x2 is 5 and x1 is 0. So 9 over 2 minus 5 over 0, this will yield us with a 7 over 5. In terms of decimals, this would be a 1.4. in terms of a mixed numeral, this will be 1 2/5. So for every 1 we are going across, we are going up by 1 2/5, or 1 40%. So we can see this here, every 1 we go across, we're going up by 1 and nearly half, it's like about half. All right, so now that we've got our corresponding A and B, we can just go ahead and write what our full equation is. Y is equal to 2 plus 1.4x. Now, if you go ahead and put this in and you leave it as y is equal to 2 plus 7/5x, that's still fine. And it really just depends on what type of criteria the question is asking you to put it in, or what type of format. If it says to 2 decimal places or 1 decimal place even, you know we have to write a decimal. But if it doesn't say anything, we can accept either type. So when you're trying to find an equation of a straight line, but you only have been given 2 points and visually the y-intercept has not been shown to you, these are the steps that you need to do. Now, I'm not going to explain this. I'm actually just going to go through this in the next example. But pause this video if you want to have a read of this process. This here can help you determine what the equation is going to look like when given 2 points. So for now, last example, we'll look into example 18. This right here, we are going to again use the same template, y equals a plus bx. And we are going to use 2 points that have been provided to us. I feel like I've been moving this quite a bit. My head is always in the way of the right information. We've got a 2, 1 and a 4, 10. Now, what I mean by visually the y-intercept hasn't been shown to us, we don't know what this is. We know what the x-intercept is. And even then, that's like 1.75, I'm not too sure. We know that this will keep going down until it hits a particular point, and we are in negative territory. So we know that our y-intercept has to be negative based on this scaling of this drawing. So that's a bit of a clue to know if we have done this correctly. So let's go ahead and label the corresponding x values. This here is x1, y1, x2, y2, because reading from left to right, x1, y1, and x2, y2 are here. And remember that our template formula, our template is y is equal to a plus bx. Now what we can't do is provide a. What we can do is provide b. And that will give us one of the answers, and then we'll have to do a bit of substituting to get a. So let's find our b. What is our y2? 10. And our y1 is 1. So it's a difference between 10 and 1 as a ratio over the difference between 4 and 2. So in other words, this is 9 over 2, which is 4.5. So 4.5. Our slope, for every 1 we go across, we're going up by 4.5. So at this point, you're kind of thinking, how do we get a if it's not visually shown to us? And what do we do in order to do this? Well, what we can do is we can fill out this part of the formula. We know that our corresponding slope for this graph here is 4.5. Okay, that slope is 4.5. So what we can do is, knowing that when x is equal to 2, the corresponding y value is going to be 1, we can plug this point. In fact, we can plug any point within this line, but we can plug this point in here, and every single variable will be filled out except for a. And whenever you only have one variable by itself, you know you can solve for it. So in other words, we are going to sub 2, 1 into the equation. So what we'll end up getting is 1, okay, so remember we're replacing y with 1, is equal to a plus 4.5 times that corresponding x value, which is 2. You can't just choose any random number, if it fits on the line, it has to be the corresponding pair. So if I'm substituting 1 into here, I have to substitute 2 as my x value. Okay, I can't just choose 1 and then 4, because those are not paired up. They're two different. They rely on the same line, but they're not the correct pair of coordinates. Now that we've got this, we can do a little bit of tidy up. We know what 4.5 times 2 is. This is 9. So now we're in this part where 1 is equal to some number added 9. Well, we can use brute force, use logic, or we can just use a bit of inverse operations. And what we'll land with is A is going to be equal to 1 minus 9, which is -8. And that checks out because we do have this line that keeps going down and it hits the negative of the y values, and we're expecting a negative y value. So our corresponding formula will be y equals -8 plus 4.5x. And that there will be your final solution for this answer. Here are the questions that you need to do for exercise 5F, page 340, 1, 2, 5, and 7. Best of luck. Hopefully you guys enjoyed the writers camp. Once you come back and watch this. Thanks guys. See you in the next video.